Hello everybody, in this video we are going to continue solving another problem live from LeetCode Top Interview 150 problem list. So far we have solved all the problems up to minimum window substring. If you haven't checked out my videos on those problems, please go to my channel and check them out. In fact, that finishes the third section of this problem list, the sliding window section. So basically we have solved all the problems from the array/string section, then the next was two pointer section, and the next was sliding window section. And now we are moving to the next section called matrix, and we'll pick the first one from that. Okay, so the problem is called valid Sudoku. Well, I can guess what the problem is from the title. It's of medium difficulty. So let's read the problem and make sure we understand all the details. Determine if a 9 by 9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1-9 without repetition. Each column must contain the digits 1-9 without repetition. Each of the 9 3 by 3 sub boxes of the grid must contain the digits 1 to 9 without repetition. Yeah, these are the rules, basic rules of Sudoku. Hopefully all of us know that. So those are the main things we are checking, or those are the things we are checking. Then note, a Sudoku board partially filled could be valid, but it is not necessarily solvable. Yeah, that is true. Only the filled cells need to be validated according to the mentioned rules. Yeah, so there might be empty cells like indicated in this example. So, okay, so let's take a look at the example. In the example one, they have given a board like that. Oh, wow. Okay, so I don't know why they are giving the board of numbers as characters. Oh, I see. I think the reason they are giving it as characters is because they want to have these empty cells denoted by a dot. Yeah, they are denoting an empty cell by a dot. Okay, so the thing to note for us is that the whole 2D grid of 9 by 9 is given to us by a two-dimensional array of chars. Okay, so in that case they are saying true, and basically the way is like, okay, none of the, I mean, like you would manually verify, right? Like, hey, does the first row contain all uniques? Yes, they do. Second row contains all uniques, third one does, and so on and so forth. And then we will check the columns, and we would check each of these 9 sub boxes, right? So yeah, even this contains all unique, the first sub box, second sub box, third, and so on and so forth. And if all of them is true, then it's a valid partially filled Sudoku. Okay, so the example 2, okay, that's not very readable. They haven't given it in a pictorial form, but in this case they are saying the output is false, and that's because the phi in the top left corner being modified to 8. I see. So which makes basically the phi duplicates. So let's see, top left. So this phi has been modified to 8, and that makes 2 8s in this box basically. So that's why in example 2 it returns false. Okay, makes sense. I mean, okay, let's look at the constraints. The length of the board's first dimension is 9. The length of the board's second dimension is also 9. And I see. So board of ij is a digit between 1-9 or it is a dot. So those are the constraints given to us, and we can assume those are true. Okay, cool. I mean, like it's a pretty straightforward problem. Maybe the medium difficulty comes from, like, if we want to do it very cleanly or good code. I don't know. It seems to be easier than medium difficulty to me, but we'll see. Maybe I'm missing something. So the approach is very simple, right? So what we'll do is we'll basically have for each of the cells, for each of the rows, there are 9 rows, right? And for each of those rows, we want to figure out what numbers already exist. And when a new number comes in that row, then we say, okay, hey, basically, is that number already there? If it is there, then it's invalid. The Sudoku is not valid. If it is not there, then we can just say add that number to that row, right? And similarly, we'll do it for column, and we'll do it for these sub boxes, as they call them. Saying another way, what I'm trying to say is okay, so actually maybe that wasn't the best explanation. A better explanation is, let's scan through each of the numbers in the grid, in the 9 by 9 grid, right? And for each of those, so when we look at 0, 0, 5, so let me write down here, right? So we are basically scanning the whole board, and here the row 0 and the column 0 has a number 5 in it, right? So the digit is 5, so D is 5. When we do that, we say, okay, first of all, for this number, check row 0 for 5, right? Always we are checking for 5, obviously. Check column 0 for 5. And let's number these boxes, right? So let's say this box is box 0, sub box. This box is box 1, box 2, box 3, 4, 5, 6, 7, and 8, right? So check box 0 for 5, because this 0, 0 belongs to box 0, right? So if, sorry, I made 9 there by mistake. Okay, if any of them are true, as in 5 already exists, then it's false, like this Sudoku is not valid. And if none of them, then we just say add, actually here, check 0 for 5, if exist, return false. Let me just, if exist, return false, otherwise add 5 to row 0, right? That's what we are doing. And similarly here, we do the same thing for that column, right? If exists, return false. If that 5 exists already, otherwise add 5 to column 0. And same thing here. If exists, return false. Otherwise add 5 to box 0. And if we do this for all of them, all the numbers in the whole grid, we are done, right? And if all of them, so this is for each, let's say, now the algorithm comes for each R, right? For each C, this is almost like writing the code, but let me just finish the pseudocode. I don't think it's going to take long. Let's say D equals, what is the digit at row R and column C, right? And after that, we basically check row R for digit D. I'm just genericizing what I already wrote, right? Otherwise add D to row R, correct? And similarly, column C, this becomes D. You get the idea, right? So that's what we are doing for each of those. Of course, if there is no digit, I mean, there's small detail here. If the character at R comma C is a dot, then skip, right? I mean, then skip. Otherwise do all of this, right? So anyway, I think that's the algorithm. Once I write the code, if it is already not clear, I'm pretty sure most of you understood. Then once I write the code, then it will become clear. So okay, so how do we do this? So then the question is, how do we check this very quickly, right? I mean, the easiest way to check this very quickly is to have arrays for 9 rows, 9 columns, and 9 boxes. So it's a 2 by 2 array. So okay, so this part is interesting. Well, a little bit, right? Actually, I think I can write the code, and I think you guys will understand what is going on. So let's allocate rows. Sorry, this is a 2D array, right? And that means the first dimension says which row 0, row 1, row 2, etc. And the second dimension is the digit 1, 2, 3, 4, 5, 6, 7, 8, 9. And the value is true or false. Is that digit already seen, right, in that row? Okay, so here we say new Boolean. Actually, I don't even need an int was muscle memory, but Boolean, and we say 9 by 9, right? And Java initializes all these Boolean arrays to false by default, and that's what we exactly want, right? Columns, same thing, 9 by 9, and then int sorry, not int, boolean boxes equal to new boolean also 9. There are 9 boxes and each of them needs to store whether 9 digits, one of the 9 digits has been seen. So we need these 3 boolean arrays, right? And now what we do is we look at int I equal to, or let's call R and C like we did in the pseudocode, I think row and column. R is less than board dot length plus plus R for int C equal to 0. C is less than board of R dot length plus plus C. So we get R and C. We are basically going through the whole board. If board of R C equal a dot, then we continue. We basically don't do anything. We skip it. And otherwise, we need to get the digit. Well, or the, yeah, digit equals, let's see, this we have to be careful of off by 1 because arrays start at 0, like all these arrays, and digit is 1 to 9, right? So we have to, board of RC is still the character we are getting, but we are subtracting 1 from it. So if we subtract 1 from it, 1 will become 0. So I should call this digit index, right? 1 for 1 will get 0, for 2 will get 1, and so on. For 9 will get 8. And that's what we want. We want, because we are going to use this to index into all these arrays, right? So digit index is board of RC minus 1. And Java allows these ASCII subtraction for all these characters. So I think this works. And then all we do is we say, I'm just going to make this a bit shorter, DI, right, digit index. And I say if rows of, what is row, rth row, and for the digit DI, right? Hey, does the rth row contain this digit already? If that is true, or does the cth column contain the digit D, a digit already, or boxes. Now here we need to figure out how to go from R and C. Okay, so I need that a little bit. Okay, so I'm going to say box index equals get box index R comma C. So from the values of the row and the column, we will get the box number, right? The box number, like I said, this is the 0th box, the top left, then the middle, top middle is the first box, second, third, fourth, 5, 6, 7, 8, right? So we'll get that. We'll write that helper in a little bit. But box index, so does that contain the digit already? And if so, then we return false, right? Which means this digit is already there in either that row or that column or that box. If not, we just update it, right? We say rows of R DI equal to true, calls of C DI equal to true, that we have now seen it, and boxes of box index of DI equal to true, right? And outside the two for loops, we say return true, that we never found a return false condition, which means all the digits are good in their own rows, columns, and boxes. Okay, so now what remains is get box index, right? So let's implement that. Private int get box index. Given a row and a column, get the box index, right? Okay, well, how do we do this? I mean, we can do a bunch of if conditions, right? Like I'm thinking we should find a slightly better way, but we could do if R is less or equal to 0, sorry, greater or equal to 0, and then R is less than 3, and then column is certain value in range, then, you know, box number equal to 1, right? We could do that. Like basically for box 1, R is bounded by 0 and 2 inclusive, and column is bounded by 0 and 2 inclusive as well, and we could do that, right? But I think what will be much faster is actually literally this, actually. Private static final int box indices. Let's call it, actually, since it is private static final, I'm going to do this box indices, right? And let's just hard code box indices for each of the cells in this 2D array. Actually, it's a 2D array, right? And we can just literally do this. We can say 0, 0, 0, 1, 1, 1, 2, 2, 2, all right? And then we just basically copy paste that 3 times. Then the fourth one becomes 3, 3, 3, 4, 4, 4, 4, 4, 4, and then we copy paste that twice. So those are those boxes, box indices, and this becomes 5, 5, 6, 6, 6, 7. Well, what happened here? Oh, this is 5. Sorry about that. I'm like, why did I not reach 8? Okay, 5, 5, 5, 5, 5, 5. Okay, sorry about that. And then 6, 6, 6, 7, 7, 7, and 8, 8, 8. And just copy paste this 2 more times. Okay, so if we do this, then we actually don't even need this helper. We can index into this array with R and C, this 2D array, and that gives us the box index. So we say box indices of R, and C. There you go. What's going on? Okay, there you go. So that is what gives us the box index. And this will be really fast because this static final, this will be defined at compile time. There is no computation involved for this. And we literally look it up. Like, we take R and C value, we look up, hey, if you want a box index for this row and that column, right, we'll just get it, right? And it's just constant amount of, very small amount of memory. So I think I like that approach. Yeah, and memory usage is well worth it. And it's static, like I said, so it doesn't even, yeah. Okay, so this one should work, unless I have some bugs. I thought of manually running it, but I think it's simple enough that I want to just run on the, yeah, there you go. Okay, so the 2 cases here work, but let's run on a bigger test case or test suite and see what happens. Should be pretty fast too, like, there you go. Okay, that I'm not super surprised by, or surprised by 100%, because I think the amount of computation we did is really, really tight, and especially this trick helps us do 3 or 4 if condition checks for every cell, and multiply by the 9 by 9 by 9 by 9, right? So anyway, so that's that. I think very simple problem. Hopefully that was easy to understand. Hopefully you're liking what I'm doing on this channel. Please consider subscribing to the channel and hit that thumbs up button on the video. And I'll see you guys next time.